once having liquid water. Now Opportunity landed over in here and eventually explored this crater called Endurance, and then over several years made it all the way down to this much larger crater called Victoria. It spent 2 years going around and inside Victoria, and is now heading farther south to an even bigger crater called Endeavour. And let's hope it makes it. Okay, so this was a stroke of incredible luck. This is basically a very boring, in terms of its visual appearance, flat plane, but it's pockmarked with some of these little craters. Opportunity just happened to land. It rolled inside its airbags and rolled to a stop at the bottom of a little crater called Eagle Crater that's about the size of the room we're in right now. And right just a few feet away from the landing platform is this beautiful outcrop of exposed rocks. Steve Squires, the principal investigator for the mission, and I strongly encourage you to read his book about the rovers, called this an interplanetary hole-in-one. They could not have asked for a better place to land. On just the 13th day, the rover drove right up to this outcrop. Notice these beautiful layering, which right there indicates liquid water like sedimentary rocks on Earth. This rock's snout is about the size of a loaf of bread. You'll also notice, and I'll talk about these more, huge numbers of these little round pebbles. I'll talk about them in just a minute. Okay, here's one of these pebbles called a blueberry. This is from the microscopic imager of snout. See these beautiful layers here. The rocks are soft and layered and a little bit reddish in color when you look at them in natural color. As I remember, this is really cool in 3D. Okay, so these little round pebbles were nicknamed blueberries. That's actually, they're about the size of blueberries, and in certain wavelengths they have kind of a bluish color, although if you looked at them in real life they would look reddish. And it turns out that the chemical analysis shows that they're made of minerals that were dissolved in mineral-rich water and later precipitated out as the water slowly evaporated. These things are harder than rock, but they fall out of these soft outcrops as the rocks are eroded by wind-blown sand. In fact, let me just go back for a minute. You can see here, this one's still stuck, but as this rock gets eroded, eventually this blueberry is going to fall to the ground. So these things pile up on the surface in enormous numbers. I mean, there are millions and millions of these blueberries strewn all over Meridiani Planet in enormous numbers. And the chemical analysis showed from these instruments, they ground a bunch of them up with a rad instrument, did a chemical analysis. These things are rich in hematite. Not only rich in hematite, they're rich in the form of hematite that on Earth forms in liquid water. So the spectral signature that Mars Global Surveyor saw from orbit was seeing the spectral signature of these blueberries. Question?
Has this process been duplicated in the laboratory?
I'm not sure if it's been done in the laboratory, but rocks on Earth show this unmistakable, you know, like the rocks that are rich in hematite of the same type on Earth, they know from the detailed studies that they're made of, that they formed in the liquid water.
There's no blueberries on Earth.
Yes, there are blueberries, yes. Especially like in the desert regions of the Southwest, they find things that are almost exactly the same thing. And a lot of them are formed like in dry riverbeds and things like that. So the association with water is really ironclad, which is really cool. So here we just see a trench dredged up by the wheels. The soils here, and once again you can see huge numbers of these blueberries. The soils are much darker than those in Gusev Crater. But when you dig down, notice the blueberries are all kind of on the surface. You don't really see them just a few inches below the surface. Another evidence for liquid water is they looked at a lot of these rocks in this outcrop, and they have, I love this word, a real technical term, vugs. And I don't think it stands for anything. I think it's just vugs. But these are gaps where in rocks there were once minerals that had dissolved in liquid water, but they're softer than the rest of the rock, they later erode away. And the chemical analysis of these rocks in the outcrop in Eagle Crater found that they're also rich in a mineral called jarosite that on Earth forms in water, primarily in acidic lakes and hot springs. So now we're starting to get real indications of like a past Martian environments, kind of acidic or geothermal areas with acidic water. So here we find also that these rocks are very, very rich in salts, just like some of the rocks in the Columbia Hills from Spirit. So after a few months, it left Eagle Crater behind. I think this is really a beautiful image here. So it left Eagle Crater, never to return.
Aww.
But it had bigger and better things to explore. This is another one of those really little impact craters. This one's called Fram, once again caused by a very small impactor that would burn up in Earth's atmosphere. And on the distance here is the rim of the much larger crater called Endurance. And on Sol 90, you can see it's getting closer to the rim of Endurance. Now, this is interesting. I mentioned earlier that these scientists were working on Mars time. Well, Jim Bell writes in his book, by the end of the rover's 90 Sol primary mission on Mars, people were tired, irritable, and yearning for the good old 24-hour day that we're used to on Earth. It's just not possible to live on two planets at once, especially if you have a real life on one of them. So what happened is after a few months, the mission manager said, we're breaking up the teams. Everybody go back to your home institution. So Jim Bell, who's from Ithaca, New York, went back to New York after being 3 months in LA, and they just basically said we can do all this stuff by doing everything remotely through the internet and telecommunication. And it turned out everything's worked fine, and they can still program the rovers, still do the science. They didn't really know what it was going to be like to operate these rovers. So after a while, they just realized they didn't need everybody together in one place. And here we can see approaching Endurance on Sol 115. You can see this is a pretty good sized crater, a lot bigger than Eagle. And voila, here we go. This isn't quite as big as Bonneville Crater. It's about 145 yards across, 66 feet deep, about the size of maybe a small football stadium. So you can see here some really beautiful dunes, but unlike Bonneville, that was the one that Spirit went to the edge but didn't go in. You can see here already there's really nice layering in these rocks. So the scientists, when they got here, not knowing how long it was going to last, like, we're going into this crater. We want to explore this crater because it goes deeper, which means you're sampling a larger time sequence in Martian history. So here we can see at the rim, what they were doing here is looking for the safest place, the shallowest slope to venture into the crater. And here we can see a blueberry, really beautiful picture embedded within these sedimentary layers. Eventually the blueberry will fall to the surface after that rock gets eroded. Here we see a rat hole on the slopes of Endurance, and you can see these sockets here where there used to be a blueberry, but they popped out as the rock was being grinded by the rat instrument. And now you can see it's venturing into the crater. Really, you see this beautiful layering on the walls of the crater as it's descending. This is a fracture that probably was related to evaporating groundwater. And here's a diamond. Genus is the name of this rat hole. This is now 66 feet down from the rim. So, the rover did a really great job of descending the crater.